When a bank pays interest on both the principal and the interest an account has already earned, the bank is paying compound interest. Compound interest is an example of exponential growth. You can use the following formula to find the balance of an account that earns compound interest. Let A equal the balance, that's capital A, capital P equal the principal, that's the initial deposit into the account, lowercase r now, the annual interest rate expressed as a decimal, lowercase n, the number of times interest is compounded per year, and lowercase t, the time in years. You can think of the principal p as the initial amount in an exponential function. Y equals a times b to the x power. Note p is taking the place of a. The rate of change is the annual interest rate divided by the number of times interest is compounded per year. You can think of 1 plus r over n as the growth factor of an exponential function. Note this replaces b in the standard or general form y equals a times b to the x. Also note the number of times interest is compounded is the number of years times the number of times interest is compounded per year. You can think of n times t as the independent variable of an exponential function. So note n times t is taking the place of x from our general form y equals a times b to the x. Problem 2. Compound interest. Finance. Suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5% interest, compounded quarterly. What will the account balance be after 18 years? Consider what you know. You know a $2,000 principal in the account. You know 4.5% interest rate. And you know that the interest is compounded quarterly. Consider what you need. You need the account balance in 18 years. So make a plan. Use the compound interest formula. Note our compound interest formula. A equals P times the quantity 1 plus R over N raised to the NT power. And substitute. We'll substitute the values we know, those are P, R, N, and T, into the formula to find 2,000 times the quantity, 1 plus 0.045 divided by 4, raised to the 4 times 18 power. As we simplify, we find that's 2,000 times 1.01125 raised to the 72nd power. Using a calculator, we find that the balance will be $4,475.53 after 18 years. Not a bad way to put a bank account to work for you. Your turn. Finance. Suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5% interest compounded monthly. What will the account balance be after 18 years?